This one wants you to factor the polynomial. And when I first look at it, I'm like, hey, this is one of those that's in the form of, whoops, ax squared plus bx plus c. And I'm thinking to myself, okay, I'm going to have to use the AC method where I multiply the a and the c. But then I come over here and I look at them and I'm like, I got to multiply 36 times 169? Where is my calculator? I can't do that in my head. And that means it's going to be really big. But then I'm staring at it and I'm going, wait a minute. 36? That's a perfect square. 169? That is also a perfect square. Could this possibly be one of those special cases? Yes, it is. The other special case was on problem number 6, which was a difference of two squares. This guy is a perfect square trinomial. Although, just because he starts with a perfect square and ends with a perfect square, doesn't necessarily mean it is a perfect square trinomial. You have to check that middle term. Your 36 comes from 6 times 6, and your 169 comes from 13 times 13. The big question is, are you going to get 156 for outsides and insides? When you multiply your outsides, 6 times 13, what's that? 60, that is 78. And when you multiply your inside, 6 times 13, that is another 78. And when I add those two together, well, look at that. There's the 156. So it is indeed a perfect square trinomial, which means what you're going to get here is for the 36, it was 6 times 6. So, and then you don't forget there's this n squared here. So you're going to have a 6n here and a 6n there. For the 169, there's no variable, so it's just 13 and 13. And that looks like a B. Sorry, 13 and 13. And because you have a positive here and a positive there, it's a positive 169, which means it's either going to be a positive times a positive to get a positive 169, or it could be a negative times a negative to get a positive 169. But because my middle term is a positive 156, that means I had to have a positive 78 and a positive 78. So outsides and insides, to get positives, I'd have to have two positives there. Positive times a positive. And then, of course, the quickest, easiest way to write this is a 6n plus 13 in parentheses to the second power. I don't think Mobius cares. You can probably type it in this way or you can type it in that way. Hey, let's go back to Mobius and look. Let's see here. That's not Mobius. That's my YouTube channel. Here we go. Just says factor the polynomial. So let me go 6n plus 13, parenthesis, 6n plus 13, close the parentheses. How'd I do? It liked it. So let me try to do it again here. Let's see. I was trying to see if I can do it again. Try a different problem. I can't find that. Let me see. Down here. 7. Nope, I can't find another way to do it. Seems like they should give me an extra problem to try. But it took it that way. I guess maybe I can backspace up here. Oops. Let's go here. And I wonder if I can highlight this and do this. Trying some, oh, it worked. Look at that. Backspace squared. And now hit, how'd I do? It liked it that way too. I guess it doesn't care. It doesn't matter. Anyway, the 36n squared plus 156n plus 169 was a perfect square trinomial. So, but you have to check that middle term because you're not always going to get a perfect square trinomial. So just be careful.